Hello ROS developers. Today we are going to see how to manually tune the PID of a ROS-based robot. So imagine that you have a robot that has some joints and that you want to control those joints by using the ROS controllers. Then in that case, if it's a joint position controller, you will need to tune the PID values. So that's what we are going to see, how a manual method for doing this tune of the PID to find the correct PID values. This is a manual method that works more or less, okay? So don't expect too much. On the video that we will do later in another day, so we'll show an evolutionary method that you can apply in order to find the optimal values. But that will be in another video. For today, we are going to use this robot, the R robot that is provided by Gazebo. And this robot contains two joints. One joint here, joint number 1, and another joint here, number 2. We are going to see how to tune the joint number 1. And then you can do the same procedure for joint number 2 and then do it as a homework. And let me know if this works for you or not, if you have any problem. Okay, so let's go. Then here, oh, sorry, I hide, yes, so I want to put it smaller. Great. So here, if you probably know how to work with ROS Control, then you know that you have to create this config file. That is the one that indicates for each one of the joints which controller you are going to use. In this case, is joint position controller, and then the PID values. So here is for joint 1, here is for joint 2, and the PID values that I have set here are just random values that I put it just for starting. And those are the values that we want to find with this method. Okay, so we are not going to talk about the rest of the configuration file because it's not the subject of this video. In case that you don't understand what all this means, then you have to study ROS Control, how does it work? And for that, let me recommend you this course that we have at the Robot Ignite Academy. That it's very interesting course that will give you an introduction to ROS Control. So will make you learn actually how to use ROS Control, how to configure for the URDF or your robot, the transmissions, the plugins, how to configure everything. So have a look at this in case that you don't understand how this works, okay? So then let's go. So we need to find those values. And for that, let me launch first the controllers of this robot, because as you have seen while I was starting, the robot was just swinging around because it had no control. I had to launch it. In my case, I haven't launched it with the simulation. So here it is, I'm launching it, and this is loading. Let me see, because I have here a dot indicating that something has been modified. So let me relaunch it again. I have saved this file, and let me relaunch the control. Okay, so now those joints are controlled, and let's see how those PID work at present. So I can send a command to the joint and indicate to the robot, hey, please go to a straight position parallel to the ground. Let's send this command and see how it looks. How does this controller perform with those PID values? So let's send it, and then, okay, so far so good. Not too much. In theory, it should go like this, okay? So it's not doing like that, then it means that the PID values are not correct, but that's why we are here. So let's go and find the proper ones. Then for this, we are going to use a graphical tool that is called RQT GUI. So launch it with this command, ROS run RQT GUI, RQT GUI. You launch this tool, and then a new X window will appear with this tool. Because we are on the ROS Development Studio on a web environment, in order to see an X Windows tool, we need to open here in Tools, the graphical tools. And there it is. So it opened the graphical tools with the RQT GUI on inside, okay? Great. So now, what is the procedure that we are going to follow? First, we are going to send to the joint a sinusoidal value. So it will be publishing on that topic, the same topic that we publish here. We are going to publish a sinusoidal value that is going to oscillate, make the joint oscillate. And then we are going to monitor the actual position that the joint actually achieves, trying to follow this sinusoidal value. And then that's going to be the difference. And based on that difference, we are going to manually tune the PID values in real time, and until we achieve that the joint is following correctly the sinusoidal value. Okay, so first thing is to publish the sinusoidal value. For this, we go to Plugins, Topics, and Message Publisher. Great. So here we have, and let's select the topic we are going to publish. And in this case, you can select from here, but it's too long name, so I prefer to type it. And is for that specific robot, for that specific joint, the value of the topic that contains the position controller is this one, position controller /command. Okay, and it's a float 64. And of course, this topic here will depend on your robot, on how is your robot name and how you have configured the controllers. So, but because of those names here, joint 1 position controller, that depends on how you have configured the URDF of this. Then we have this. Let me increase the frequency at which it's going to be published. That sinusoidal, it's going to be 50 Hertz. So I'm trying to publish quite fast. And let's add this as a new publisher. Okay, by adding this, it says, hey, I'm going to publish a float 64 at this rate in this topic. But how do we indicate that we want this to publish a sinusoidal value? Okay, so press here in data, and here you have the expression that you want to. So here, if you double click here, is where you are going to express the sinusoidal value. For that, we express sinus of time. That time is the time at which it's going to be published every time. So in this case, time is indicated by I letter. So let's say I, and then divided by the this is the speed, the rate and the speed at which we want to be generated this sinusoidal. So basically it indicates the frequency. So let's put here the same value as we have put here in the frequency of the topic, and close. Then we can, this sinusoidal, this is indicating the frequency, okay, at which is going to be oscillating the sinusoidal. But then we have to specify also the amplitude, the angles between which and which is this sinusoidal going to oscillate between. So let me start with a small value like 0.5. And that means that this sinusoidal is going to send values to that topic between minus 0.5 and plus 0.5. This joint is a continuous joint, so it can rotate as much as we want here. Okay, so here we have, and now we have specified, and in order to start publishing, we have to press this square here in order to activate. So as I press, then the robot starts to move from one side to another. Okay, it's not following the sinusoidal, the proper one, but that's okay. Let's see now how is this joint following the sinusoidal value. For that, what we are going to do is to plot the value that we are sending, the sinusoidal value, and also we are going to plot the actual joint position and see what is happening there. Let's go to Plugins, then Visualization, and Plot. Okay, so it opened here a new tab. It depends on how you have configured RQT GUI. that it may appear this, instead of a tab, it may appear like a floating window or on the side. It depends. You can configure everything here in RQT GUI. I'll leave that for you. Okay, so let's go for the topic that is receiving the command. Okay, so first let's plot this. So it's called our VOT joint one position controller command. That's the one that we are publishing, as you have seen here. Yes, command. And then in order to plot, we have this topic contains a message that has some data on it, because what we are publishing there is this type of message, float 64. But we want to access to plot the actual value. For that, we have to add the field data. That is the one that contains the value. And then press plus. So there it is. So we are seeing here the sinusoidal. It's a small one because it's between 0.5 and minus 0.5. But you can see that it's oscillating. Okay, let's go now and add another one, another topic. It's the topic that contains the actual position of the joint. And for that, we have to go to the same topic, RBot, joint position controller, state, process value. And let's plot it. Okay, so we can see that this joint is not getting close to the joint value and to the sinusoidal command, and also it's not even following the sinusoidal, so it's like lacking some following some synchronization of this. Well, that's basically because it cannot. So it's trying to go to one side when the sinusoidal is sending to the other one. So there is no enough PID value. So let's go now and modify the PID values in order to try to achieve that those two lines get together. For this, let's use the dynamic reconfigure plugin. So it's another plugin here, configuration dynamic reconfigure. What this plugin allows us is to modify the PID values in real time. So we can see how this is going to change based on the values that we modify without having to run everything again and start everything again. That's very convenient. So you have this window here, then go to the RBot, and here are all the parameters that can be modified in real time by that controller. You go to the joint one position controller and then PID. In your case, in your robot, you will have different names here, but basically is you have to find the one that corresponds to your joint. And here we have the PID values. As you know, those are the values that we have by default that I put on the here on the file. Okay, so those 100, 100. Okay, so let's now modify this. For example, I'm going to try to increase a little bit more the P value. Okay, so I'm going to write there and type a. Okay, so I have put a 10, and now let's accept that. Then now it looks like it's going further. So okay, so it's doing something a little bit strange. Why is that? It's because the 0 position of the robot is on the when this part, the black part, is looking towards the top. So that is why it should be oscillating between minus 0.5 and 0.5 around there. Okay, looks like still it's not possible because it's not following the same structure as going up and going down. So what I'm going to do is to increase a little bit more. Let me just put here, for example, 50. Okay, now it's going stiffer, and you can see that it's following better, not so good, but improving something. Yes, okay, so it's going up and then it's going down. It's going up and going down. Okay, great. Then these values looks like more or less, but I will increase a little bit more the differential one in order to include some smoothness of this. So let me increase 10 by 10 and let's see. And you can see here visually also how the movement is becoming like following. Yeah, so it's going up and going down. It's going up and going down. One of the problems of this method is that this is a continuous joint, and because it has been rotating in one side on the other, then it may happen that the total value of the joint, that is the one that represented here, is too large. So it's not between 0.5 and minus 0.5, but the equivalent, if you modify this value of the angle into the range of minus pi and pi, that is the actual real range of this joint, then you will see that will be oscillating more or less in the same way as the blue line. Okay, so now we have more or less synchronized the red one with the blue one, more or less. So now what it remains is to, let's see if this can move around the whole circle. So doing a complete circle. Okay. So for that, let's modify here the sinus, and instead of moving between 0.5 and minus 0.5, let's say between the two ranges of the joint, that is pi. So it's minus pi and plus pi. So that's the whole circumference. So there it is, and then there it goes. It goes to one side and then it goes to the other one. It goes to one side and then it goes to the other one. Yes, because it's the sinusoidal that is going to one side and the other. And then we should see that both signals, they go more or less on the same way. So going with the same tendency. That means that these PID values are working more or less. So basically the way is just this. So once you have those values that they work more or less for you, you can go here to the controller file and then put them here. That would be 50 and here 10. And then save it. So now we are going to do one thing. We are going to, let me close this, the RQTY tool. So I'm going to close it just to stop. Let me first stop the publishing of this when it's down. Okay, so there it is. And then let me just close. Actually, we don't need to close. Yeah, we don't need to close this. Well, yeah, let me close this because sometimes there are some problems when you close and start new things. And then let's close now the controller. So let's close the controller and relaunch it again. Remember, we are relaunching the controllers with the new values. So if I launch it now, okay, new values are loaded. And then if I do the same test as I did before, by doing this test, then the robot should be in reach the position that I'm asking the joint to reach. And there it is. Okay, so far so good. So that is basically the method that I wanted to show you. I know that it's not very scientific, it's not very exact, but you know, it works. On a future video, I will show you how to do the same thing with an evolutionary algorithm, so the algorithm will find the optimal, super optimal values. And thank you very much, and remember that if you like these kind of videos, please give us a thumbs up and subscribe to our YouTube channel, where we are publishing one new video with stuff like this every day. So if you subscribe and you press the bell, you will be notified when we publish it. So thank you very much for following, and see you on the next video.